looks like we're live. Looks like we're live. Yep. Video counter saying we're live. CNBT 1311. We're still in wood rafter framing. I guess they couldn't come up with something else to call this. Well, it is wood and it is rafters, so it's okay. All righty then. You can probably tell I'm getting about as whacked out going through all this as y'all are. There is a lot of stuff in this Ching book. There's a lot of stuff in construction, materials, and methods. What are the methods? The methods is design, all the design. Soils mechanics. Just be glad I didn't make you read the soils analysis report. If this had been a 16-week course, we'd have gone through a full soils analysis for a commercial building over off Cypress, North Houston. If some of y'all want that, just email me and I'll put it up on D2L so you can read through it. But nonetheless, that's really a structural engineering thing. Architects and structural engineers, they got to work hand in hand together. So there's civil engineers. If I'm not mistaken, Texas Tech University, they have a bridge between their fully registered architectural program and the engineering department, civil engineering, structural engineering, which I think is really good. Well, anyway, I digress. Let's get back. Okay. This is the ridge, right? Okay. Whether this is a ridge board or ridge beam or whatever the heck you want to call it, I could care less. Okay. Now, the ridge board is a piece of dimensional lumber. It's not a piece of crap that you just throw up there. And then there was a ridge beam detail that was pocketed in here to make it more structurally sound. This is a collar tie, which makes this intersection a triangle, right? Okay. Well, what do we have up here? This is a ventilation at the peak of the roof. It's called a ridge vent. Continuous ridge vent, and you need. When I re-roofed my house, I took the hawks off and put a continuous ridge vent up. Now what I have to do is, oh God, all right. What I have to do on mine is come back in here, and I got to go around the perimeter of the house and put more soffit vents, okay, in, because I don't think there was enough soffit vents in, but we'll talk about that later. Okay, it's just a vent, allows the airflow up through and eventually make its way out the ridge vent. Okay, all right. Are bilouvered vents in the gable end walls. Okay, and we talked about the vents in the gable end walls. And there's nothing wrong with having both a ridge vent and your gable vents, depending on how long the roof is. You just got to be careful about short circuiting your ventilation. You don't want to overpower this. You want this to work so that the airflow will come up and then out. When we have our 3 months of triple digit temperatures, okay, and you can get these gable vents with a fan on the inside. Well, that's a funky looking fan. That'd be out of balance, wouldn't it? Make a lot of noise. All right, and some of these even have a thermostat on them. So when it reaches, I don't know, 110 degrees or something in your attic, they'll kick in and help with this. You gotta be careful about short circuiting though, because if this overpowers the convection flow, then you could be pulling in air back through here. But even if it's 110 degrees outside, it's going to be well over 120 inside without any kind of ventilation. Well over. All right, that's enough of that. What does he say here? 1 by material minimum. You better not use a 1x. I'll fire you if you designed and detailed up a ridge beam, ridge board, whatever the heck you want to call this, with a 1x. I'll fire you. It needs to be at minimum a 2x. Um, and the same depth as this. All right. So ridge vents are very important. They work very well as long as you have enough surface area underneath your eaves through your soffit to feed it. Okay. I like to say I might have to go back and redo a calculation, air balance on my house after my back heals up this summer. All right. These will be your ceiling joist or floor joist if this is a multi-story building, but it's a joist, and this is a rafter. If it goes all the way up, it's going to be what? Common rafter, roof rafter, whatever you want to call it. You're going to face nail these. You may have to put a strap. Your building code, your building code. Again, the building code may require a steel anchor strap to resist uplifting and wind forces, such as down on the Gulf Coast. Strong tie, Simpson strong tie makes these. Here again, this is a corner tie, just like the Simpson joist hangers. It says face nail 510D and toenail 216D to each side. I'm not a real advocate for toenailing, but you can't really get around it. It's not like you can come in here and weld this wood together, right? So, the devil is in the details. You will spend most of your time in the details. The structural engineer and you, the devil is in the details. All right, this is the eave attachment. That's what hangs out over the exterior wall. What's he telling us here? Rafters are framed opposite each other. Well, no kidding. And why is that? That way this force can go through there and pick up that if the wind's blowing from this side or vice versa. All right. I don't mean to diminish this at all. It's just that maybe it's just that I'm an old fart at 69 and an old engineer. Collar ties. Again, this creates a triangle, and they're face nailed. Your building code may require you to put some kind of extra reinforcing in these. All right. Critical depth of rafters. That would depend on, again, how much room you need for insulation, and you need to leave room above the insulation line so that airflow can come up and go up. And okay, see if I can draw insulation. See if I can draw insulation. Well, that's pretty ugly. Dude, there we go. There's the insulation. Okay. Now, what if you're going to foam this? What if you're going to come in and spray foam this? Well, you're still going to need some kind of ventilation. Now, some people who spray foam their attics, they bring in fresh air with their HVAC system on a timer so that they have so many air exchanges in the attic, and they still handle the ventilation with a roof deal. Your HVAC and your engineer can be a big help here. All right, and we all know rafters can bear on the double top plate. In this case, well, my apologies. God damn, what the hell? My apologies. That was a UPS delivering my wife's haggis. It got here late, so we couldn't have it for Robert Burns night on last Thursday. But I digress. This is not a history on Scottish history or any other silliness. All right. Now, this common rafter would have to be notched. You have to notch out for your top seal, your top plate. You go to Larry Hahn's videos and watch him frame up a roof or a wall. You'll see him doing this. And they may bear on the double plate of a stud wall or on a single plate when the attic floor joist is supported by a stud wall, or a masonry wall, or a concrete load-bearing wall, whatever. That's the way they work. Now, if you're going to seal off your rafter, and there was a building contractor that built a lot of houses in Jersey Village in the 80s that terminated the roof like this. There was no overhang, there was no eave, and the guy was a bozo. My mother bought a house that had this detail, and so that means when the water comes down, it comes straight down, comes down on the outside, right on the outside of your exterior wall, and um, you had to be careful about your windows. People that bought those houses had to come in with extra flashing over the windows to get the water to divert so they wouldn't pull up on top of the windows and then mitigate back in the walls. It was a mess. It's a crummy design, bad design. Um, the rafter still has to be notched at the bottom, clipped, excuse me, or seat cut. The official term in Ching's book is a seat cut, uh, um, or clipped, or whatever. Um, and these have to be done very precise. If not, your roof's going to have bobbles in it. It won't set even across this. One will be shorter than the other, and it makes for an ugly roof. And it shows a poor framing job. Um, so um, this is not as structurally sound. You may have to use uh, Simpson clip ties or something, because as you can see, all this is going to do is slide. When the forces of the roof come down, it's going to want to push out. At least this has a little notch in it, and it's easier to make this a little bit more structurally sound. But again, um, your mileage is going to vary. Okay, here's your subflooring. Before you do this, you put your subflooring in. Use that as a diaphragm. This is your solid edge blocking. Um, and this just was a really poor detail. A lot of those houses just leaked after, not too long after people moved in. Um, Especially down here in this, we get so much blowing rain and stuff. It was just a bad detail. They'd have to come in here, and they tried flashing it with a zip strap and a water lip, but still, that water would cascade down, fall down this wall. Uh, People put gutters, tried to put gutters up here to mitigate that. That's the only way you can do it. It's just try to get the water to flow away from your wall. This is just a bad deal, in my opinion. Okay. Um, the joist on a double plate, for something like this, you can do it on a single plate, um, because basically you got all this structural stuff coming down here. All right. Okay, let's move on. Um, Exposed rafter tails on a sloping soffit. Um, Closed rake. This is called a closed rake. Rake trim. That's the sideboard coming down from the roof ridge, the ridge line. All right. Rake trim with barge board. What in the world's he doing here? Cornice return. Oh yeah, I remember this. The cornice return. Um, these with your normal framing crew and construction crew for residential are pain. Again, you can see this joint. You can imagine what's happening back here. How to get that flashed. How to get it sealed. Keep rodents and stuff from mitigating into the residence. Um, it's important to consider how that roof detail turns the corner. Okay, try to stay away from this. Try to stay away from this. Um, I can walk you around my house and show you all manner of silliness. All right, this is an open eave where they just bring them out. There is no soffit underneath here. There is no soffit. This is a soffit. Okay, we'll get to that in a minute. There is no soffit. This is open. You see this? You used to see this on a lot of rural houses where they'd leave this open, and then they'd punch holes, well, they'd drill holes um, in the end blocking, and then cover that with screen wire to allow the ventilation to come up through there, like I told you on the soffit vents um, or eave vents. This whole thing is an eave, but this is the soffit, and this is a soffit vent. All right. Um, this is a nice place for wasps. Wasp love building nest up in there. Um, it's You do not see this on residential construction in around the Houston area for these tract homes and stuff. The fascia is the outside finish trim, whether it's on the um, rake board coming down or on the header at the bottom of the roof. Okay, you're going to trim it out with the fascia, and there's your roof sheathing, and then your rain drip flashing then will come over and drop down partway through your fascia. Now, this is what the gutters would be nailed to if you have gutters. And trust me, you need gutters around here. Good gutters, sized properly, not the stuff you go buy at Lowe's or Home Depot. Um, and you need leaf guards, good ones. All right, exposed rafters. All right, and we've already talked about that. Okay. Here's a cut where they terminate on the top plate. I'll push against that wall. Um, Depending on the loads, these make me nervous. I would much rather have some kind of structural tie, like a strong tie strap or something like that. But that's exposed rafters. Okay. Now let's do a closed rake. Okay. Now remember, the rake is coming down. So up here is the high part of the roof, right? And this is coming down. Okay. Here's your lookout rafter. These things are in nailed. Um, and this is your fly rafter. And this is the weakest part of your overhang. This in here, the attention to the construction and detailing must be really done here. This closed board is called a soffit. Okay, this is your barge board extended to form a drip, and this is your rake trim. Okay, much like the fascia. So the barge board and the rake trim form the fascia of a closed rake system. See, here's your fascia, and a lot of details on old residential houses, and I have this on mine. There'll be a 1x2 on that fascia board. There'll be a 1x2 nailed to that fascia board. Well, that's a poor detail. And then you extend that rain flashing out over it. It terminates right there. And any gutters then are underneath here. And what that does is it gets the drip away from your fascia board. And hopefully you don't have to replace your fascia board for many, many years from being rotten if the water just trickled down. If this rain flashing, drip flashing was back up against here, you'd have water drip mitigating back in here. But there's a little 1x2, and of course, if this is hardy board, you're not going to worry about it. Hardy plank, you're not going to worry about it rotting. All right. He mentions coordinating your rake trim and your barge board with eave fascia and gutter detail. He doesn't show you a gutter detail here. Common rafters coming down. Here's the clip. Some building codes will require you to put a metal clip in here of some sort. Depends on the wind loading. This is how you terminate it. This is a lookout. This is generally 2x4. You have a 2x4 nailer back in here that runs along the full length. And then now, how are you going to nail this? Well, the best thing to do is prefabricate this whole thing. If you can, but you're going to have to get your spacing right, to end nail it. End nail it your strongest nailing. Normally what they'll do is then they'll face nail that. They'll just nail the crap out of it with their air guns, their nail guns, and then they'll toe nail this in and try to get back to toe nail that. And then they'll put the fascia, fascia board up and nail it underneath here and nail it to that. And then the fres board is another architectural element that comes down. You see this if you're terminating brick line coming up, or sheath paneling, or outside wall sheathing paneling. All right. Now this is a slotted vent strip that runs theoretically the full length of the fascia. So that means you got to split your fascia. Most of the time what they'll do is they'll intermittently run this. And so this is your soffit of plywood or T&G boards, tongue and groove boards. Boy, that's a heavy weight. Hardy plank. Hardy makes a soffit board. Here's your vent. That allows the air to flow up through the vent, flow up that edge of the roof line underneath the decking, out the ridge vent, right? The ridge vent. Remember the ridge vent? Sure you do. You live for a ridge vent, right? Yeah. Okay. All right. All right. This is a wide vented soffit. I don't know why he considers that one right wide. And this is a narrow vented soffit. Of course, this is all drawn to NTS. Not too sure, or not to scale. I'm sorry. What you might see in existing construction is, if we're looking up underneath here, if we're looking up this way, you would see your soffit. Boy, that's a broken line, isn't it? Yeah, oh yeah, the whole drawing's broken. That's a little better. Okay, what you might see is they'll come in and we'll take a saber saw and we'll cut rectangular. This is what I have in that 50-year-old house I'm living in. We've got these periodically spaced. I'm gonna have to come in and cut some more. And this is all screen wire. This is all screen wire. Keep the birds and boogers out. So that we're looking up. We're looking up. And if you really want to be a geekoid, you figure out the volume of your attic, and then there are formulas and calculations. You figure out how much area you need along your eave, right? Now, if you only have an eave on the back side of the house and front side of the house, because the side of the house is a gable that goes all the way up, then you won't have this on the two sides. You'll have it just on the front and the back. All right, your mileage is going to vary. And this is a rake overhang. Okay, we've already talked about the rake overhang. So Um, there's your Fres board. All right, we basically talked about this already. Okay. This is a rake board with a enclosed eave with a soffit, and this is a it's just overhung rake trim. Okay. All right. Best way to do it is to get this as far away from the wall as you can afford and can frame up. Again, the devil's in details. This right here, you don't put your rookie framers doing this, doing these lookouts. This stuff has to all be right. If not, this is going to go up like this, like a snake. All right, wood rafter framing with parapets. These are some details that have. These are details, various details. We've seen these before with flooring. This is not rocket science. This is a CMU wall. So we got a bond beam or a ledger beam, whatever you want to call it, and we got the anchor bolt put in there, and then you put your decking, whatever that might be, and there you would run your flashing up. And this is a masonry parapet. Now remember, the parapet has a propensity to turn your roof into a swimming pool if you're not careful. Again, the devil's in the details in the planning. Okay. Metal or precast concrete coping. I gave y'all a detail of what I like to do up here. If you'd have an unsupported cap flashing, this stuff tends to get beat up over a period of years, especially if you've got workers throwing ladders from the outside up. Of course, this is raked back inside, so the water would run back in here. I like putting a treated dimensional lumber up here, embedded into the masonry unit, and then put the cap flashing on that. It gives it something to support to. And these walls, if they're not level going down the length of the wall, with that, what I call top plate, or whatever you want to call it, flashing plate, you can call it whatever you want, I don't care. It allows you to adjust that plate over the length of these masonry units to get a level surface to set that cap flashing, so you'll have a nice clean line on your parapet. All right, here's a cast in place wall or a tilt wall or any kind of concrete wall. If I'm not mistaken, this is called a riglet, and that's where the flashing would hook into. And it's the same deal. Depends on how you're going to absorb it. Fasten it. Here, your steel straps or anchors. These could be embedded in the concrete. If based on this detail, this would be cast in place concrete. But it could be reinforced. A precast concrete with predetermined anchor bolts. If it's precast, you might not need this. You can set these up, these cast in place anchor bolts, or it could be tilt wall on a specific dimension. Bolt this to it, make this a little heavier, and then come use a clip through here. But this shows this strap was cast in with this wall. So again, it could be tilt wall cast in place, or theoretically it could even be precast. They could have a periodic embedded metal plate, and you come in and tack weld a piece of angle iron onto that and then nail it into the side or screw it into the side of your joist. All right. What's he saying here? This is a 2x4 blocking. All right, this would be a continuous studs of wood or light gauge steel. And we've seen these details with the flooring. We're still making a parapet. Flat roof joist. Again, your flat roof is not totally flat. Okay. These are flat. This is not flat. Why it's here, I have no idea. Let me check a later version of the book. Yeah, it's still in the book. I don't know why the flat roof is there. This was flat. Anyway, so this has a small overhang and even a soffit. You might actually get these soffit panels pre-manufactured or done in a shop instead of having to figure out how you're going to do this out in the field. Let's see. You already know what that is. You know what that is. You know what that is. There's your blocking. There's your thermal insulation. Now, there's no way to ventilate this with a soffit vent. So I don't know what this is. I don't know where this is going. I have no idea where this is going to go, how it's going to mitigate, because generally, if you don't have convection where you've got the hotter air up here and the cooler air down here, okay, heat's going to rise, right? So if it's super hot and you've got a convection coming out, like in a conventional roof, but it's a detail. Doesn't mean it's a good one. Let's see. Here's one with a cast in place, tilt wall, precast, whatever. And again, we're showing a horizontal movement for the air. He is showing an offset now for the interior wall skin. Most likely, if it's residential, even if it's commercial, it's probably sheetrock. Commercial is going to be 5/8. Walls for residential is 1/2 inch. You could put a vapor barrier and a thermal barrier in here, and then put all that up against it. What do we got here? There's another detail. He's just using double blocking up here. Flush edge connections do not protect the exterior wall. Well, I've already told y'all that. Flush edge protection do not protect the exterior wall from weather and are especially susceptible to leaking. I told you about the houses in Jersey Village that were done. And by the way, that contractor was my old track coach in high school. Yeah. So, roof sheathing. We're at 33. We may not get through this. Roof sheeting over wood or light gauge material rafters typically consist of APA. That's American Plywood Association, and you want it rated. Okay. All right. Let's see. Panel roof sheathing. There's some more rules of thumb. It'll be stamped on the plywood, and you can go to the APA and your building code, and they'll say that X kind of plywood you can span this much, blah blah blah. Again, your mileage may vary. Okay. Nail or screw. Anytime they say nail, you can also screw it. They'll mostly nail it probably because it's wood, and they'll just use their air nailers, so their nail guns. But you could screw it. You do want to offset these joints just like you do with brick and your paneling. The direction of face grain perpendicular to the framing. Well, it's plywood, so I mean, this has face grain, then that's got the next veneer grain coming in. They stagger up and down. Direction of the face grain perpendicular to the framing. Okay, fine. Direction exterior grade plywood. All right. Yeah. Okay. Again, that goes back to APA and your building code. What you're going to use. Most all this all the plywood's got an exterior glue, believe it or not. That doesn't mean it's marine plywood, but it's got an external. They use an external glue. Do not use OBS, oriented strand board, for your roof decking. That stuff's trash. You get a little leak up here, that stuff will blow up like a grenade, and then it'll turn to mush. At least if you get a roof leak with plywood, it'll last a whole lot longer exposed to water than OBS. Okay, protect edges of exposure, of course. Soffit panels should be exterior grade plywood. Well, no kidding. And plywood does interior and exterior. It'll be stamped on the sheet. We talked about staggering in joints. Space joints 1/8 inch unless recommended by panel manufacturer. They used to make little metal clips that you would set in here when you're laying your plywood roof decking in. That would give you an 1/8 inch space. I don't see them using that much anymore. You can use a nail as a spacer. And why do you want to have an 1/8 inch space? For expansion and contraction. I mean, if this is conventional 2x6s or 2x8s, then you've got, what do you got, 1.5 inches? So you got 1.5 inches up here, so you can put the plywood in here, run the plywood in over here, and the APA is taking this into account. And then you got an 1/8 inch gap in here, and you nail that in there, and you nail that in there, and go on about your business. All right. Wood plank and beam, you don't see a lot of this. You might in some rural areas. If you're living next to a sawmill and you've got a lot of access to this, that would be fine. The most cost efficient and biggest bang for your buck is plywood. This is expensive and it's heavy, and these things do not come dimensionally stable. Not near as dimensionally stable as plywood. Okay? I would stay away from this, unless, of course, your client wants this and they're going to leave this exposed and they want it to look all pretty and everything, or whatever. Okay? All right? So, wood plank and beam framing, I'm not a big advocate of that. It's expensive, it's heavy, and again, these individual planks are not dimensionally stable, just like wood planking for the flooring system. All right, I think I've said enough of that. He talks again about bracing. Any structure needs to be braced. All right. Why is he doing glue lam again? Glue lam beam span to. Okay, we've already talked about glue lam. Plank and beam is often left exposed. Yeah, I see plank and beam framing is often left exposed to the interior with rigid thermal insulation being applied over the roof deck and a vapor retarder. So your client may want that. Maybe this is going to be a bar or a dance hall and they want a certain look and they want this vaulted and left open. That's between you and your client. Okay. And there's some advantages to that. You can run your exposed ductwork underneath here and paint all that black or whatever so people don't really see it. And all right, 625, we got 5 more pages to go. Let's go ahead and knock this out. All right, we're still at wood planking. Well, he's beating this up. this two-layer system. Okay. Oh, I see what he's doing. All right. Why you would do this, I have no idea. Again, use plywood unless your client wants it this way. All right. This planking is running down the longitudinal. This is running down the side of the building, or down the side of the roof. You're going to need more structural. You're going to need purlins. Okay. You will need purlins if you're going to do this way, so you're adding more weight to your structure. But that may be the look they want. And if they can afford it and your engineer and you are good with it, then knock your lights out. Roof beams parallel with slope. I personally think he's run out of stuff to talk about. All right, here's some heavy structural details. Okay, you need to pay attention to this. All right. For slopes 4 and 12 or greater, you can use back-to-back shear connectors. These are pre-manufactured, and but you got to pocket this out. And you got to use a router to try to get this routed out, and this is highly labor-intensive, relatively structurally sound, but it is expensive because of your labor cost. You can't just throw this up and nail it. This is a more probably labor-friendly method. Theoretically, there's no reason why you cannot use side plates for slopes of 4 and 12. What I have seen is they've come in and had prefabricated structural steel plates made. That would be a weld joint at the fabrication shop, and then they'd have these on both sides, and these are heavy lag screws, and this is a heavy steel plate, or they're 3-bolted. Could be 3-bolted. All right. Certainly easier to construct. You throw your rafters up, nail them just to hold them long enough so you can get the side plates aligned, and then do your cross drilling or your lag bolts, depending on what the structural engineer wants. All right. So there's no reason why you can't use something like that for a 4 and 12, greater than a 4 and 12. He says for flatter slopes, you can use a metal strap. Depending on the gauge of the metal strap, the gauge of this, you might get by using this on a 4 and 12 or greater. Again, your mileage is going to vary. That's a ridge connection. All right, post beam connection. We've seen this before, where we sandwiched a floor beam or ceiling beam with a solid wood tie, and they're through bolted. Again, this is going to be for a heavier loaded wooden structure, and it's going to be more expensive to construct. Now here's a heavy timber construction detail. We did some of this on that heavy timber shopping center I did in the 70s, late 70s. These were structural cedar that came down, very expensive, and these were heavy cedar timbers, and we used 20 penny nails to tag them, and then we'd through bolt them, and we didn't have to use straps, but you may have to use a strap depending on the building code and the wind loading. And then you got to worry about what you're going to do with this for your building skin. You can work that out. You're a detailer, you're a designer. Post beam connection. You come down with your rafter or your solid wood beams. Now he's using the difference between this, so that means it's heavy timber construction. And then you're going to use metal framing, angle, and then straps. There's another metal framing angle underneath here. And that's your top plate. I would think we'd use more than one top plate, but I didn't draw the detail. Alright, instead of a top plate, this is a carrier beam coming in on the inside. That's kind of funky. But in an agricultural building, I've seen this detail on barns and stuff like that. Wood post coming up. This post goes all the way up through, and you would face nail or through bolt or lag screw these joist, roof joist, or rafters, or whatever you want to call them, and on both sides. This has a sandwiched perimeter beam that sets on. There's your wood post. This one has a knee brace. This is a knee brace. Diagonal brace is a knee brace. Diagonal brace is a knee brace. Alright. You might need it, you might not. It's between you and your engineer. Here's another post and beam connection. There's all manner of ways to do this. This is built up. That one's built up. So you can read through all of this. I'd stay away from split ring connectors. That's labor intensive, and we talked about that before. All right, this detail shows a shear plate up here. This is a huge ridge beam. It looks like a glue lamb beam. So this must have a long clear span. Obviously, if this is all part of that detail, then we're using a steel beam bearing or post girder support. Now, if you think your steel manufacturer is going to be able to kick the top flange of that beam over, you got another thing coming. They're not going to do it. They're not going to do it. You're asking them to alter the hot rolled section, and this is a pipe dream detail here. Now here's the tongue and groove roof decking. Now this is heavy, heavy, heavy. Okay, if you need it like this, if you just absolutely have to have it like this, then it needs to be manufactured, fabricated. There are cheaper ways to fabricate this. This detail, but that's outside the scope of this lecture. All right, on top of this roof decking, you've got a vapor barrier. I don't care what he says, there's a vapor barrier here. Then there's your rigid foam insulation, and then your roofing membrane, whatever that might be. Okay. Blocking may be required. Steep slopes, keep the stuff from rolling over. These are purlins. Remember, these are purlins. So this is running the decking this way and not down the longitudinal distance like this is of the building. Okay. Roof section, interior support. You might have to have another glue lamb beam in there. This is like for heavy wood construction. I've seen some churches done like this. I think we went to, one remembers of a church off Memorial Drive when I was a kid that was heavy wood construction. If I remember correctly, it was. Yeah, they used this heavy wood deck, and they had it all stained and everything, and quite weird. All right, critical depth of beam, weather type closure required. It depends. All right. What he's talking about here is if you're going to notch this beam out and you need this at this point, this depth of the beam, you don't want to be cutting it out. You'll use a deeper beam and then cut out the quote-unquote non-needed structural section for the clip on the edge. This is your structural engineer's business. He may come back and say, hey, you're asking me to cut this beam, and we can't do that because I've lost I don't know, 1.5 of my beam. Do not expose the end grain to weather. Well, if the joist is running, or the roof beam is running this way, or the raft, or whatever you want to call it, is running this way, everything here is end grain. There is nothing that you can do about that. That's the way the tree grew. This is all end grain. So you may have to cap it. You may have to come in with some in this case, it would be some custom-made, expensive flashing, and seal behind the flashing, and then attach all that to it. Okay. Wood trusses, they're no different than metal trusses. We talked about that before. To avoid bending stresses in truss members, loads should be applied at panel points. This is a panel point. This is where your verticals and your diagonals meet. So your main loads need to be applied or uniformly distributed across here. That your truss manufacturer is going to give you the recommendations. Vertical sway bracing, we've talked about that, where you may have to run interior purlins along here to keep these things from rolling over. You may need a knee brace, and you may not. I wouldn't think you'd need a knee brace unless you got something really super weird going on. I do not like this detail as a structural engineer. I want that bottom cord to come out at least some distance, some good bearing distance over the load bearing wall, and then the top cord can come up. Well, that's nasty. Then the top cord can come up. You have a little bit of overhang on both sides, and then this gives you a place to put an eave or a soffit. Okay. Well, an eave and a soffit. You don't want that open. So, but again, your imagination will hold you back if you let it. Your designers, your creators, work with your engineer, work with the truss manufacturer. You are certainly not going to want this built on site. Do not do it. Let's see, span range, more rules of thumb. Again, your mileage is going to vary. You get with the truss manufacturer, just like with the bar joist manufacturer and the joist manufacturers. Come on, it's too easy to they're the ones that are the experts in building this, and they will have job history that they did, and they may actually have finished a job that you're working on, and it'll save you a lot of mental anguish trying to reinvent the wheel. Here's an interesting detail. Truss rods. Okay, so here's our diagonals, and so we have truss rods. They're metal tie rods that serve as tension members in a truss or truss beam. Now rods, thin rods, are good in tension, right? We all know what tension is. You're pulling it apart like a rubber band, right? You try to push on a rubber band, turn a rubber band into a column, and it gets all like a piece of linguine, right? Okay, so these rods are in tension. Now this is real good as long as you can maintain your forces and you don't have a force reversal in your structure. And what do I mean by force reversal? Is that the forces on the structure change from what you intended it to be designed-wise. So suddenly this becomes a tension member and that becomes a compression member. That's bad. You don't want that to happen. So if you can control the life cycle of a truss, this looks like an old wooden truss in one of them old buildings off of Washington Avenue that was built in the 1900s, that I had to go in and redo a structural analysis on. You don't want a force reversal. Thin steel rods are good in tension but not compression. Okay. So composite trusses, that's another terminology, composite trusses. They're made out of instead of the same kind of member like this would be, whether it's wood or steel or light gauge metal, it's wood and rods. I'm almost done. Yahoo! All right, with this one. Isn't that great? Yeah, 55 minutes. God almighty. All right. Well, you just have to get over it. What are we talking about here? Example of a Belgian truss. Oh, my God. Okay. This is called a Belgian truss. Member sizes and joint details are determined by engineering calculations. Well, no kidding. Okay. A Belgian truss is usually a heavy loaded, heavy structural wooden truss. Okay. As you can see here, the members are 2 by or 3 by material, minimum face width, and the trusses usually do not exceed 5 members in thickness. Okay. Now, these are heavy, heavy wood trusses. They're expensive. I would certainly, unless your client wants that look, then I'd stay away from it, because these are going to be very, very, very expensive. It can be done, and they'll carry a lot of load if they're engineered properly. But I'm not so sure you're going to find any engineers, structural engineers, that can do a Belgian truss without doing some research. All right, so we know what these are. These are purlins, okay, and that's your roof decking or your planking, whatever it might be. Let's see, and again, you're going to have to consult your building code by member thickness and your fire code. The size of compression members is governed by buckling. Well, of course. Let's see, secondary shear and bending stresses from developing the centroidal axis of truss members, and the load at a joint should pass through a common node. Well, we've already said that. All your loads, this is engineering geek speak, need to pass through a common load. This doesn't have anything to do with you architectural designing people. This is just engineering stuff. Okay, you see how thick this is? Look at that. 1, 2, 3, 4, 5 members. This is obviously carrying some heavy, heavy stuff, and probably spanning a long distance. They're trying to span something. All right, these are called heel joints. The heel of your foot or the heel of your toe. Okay, or the heel of your toe, the heel of your foot. You got toes and you got a heel. Boy, that was stupid. All right. Solid or built-up column support. This could be anything. Load-bearing wall, masonry units, wood, blah, 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 anything. All right. There's a steel bearing plate underneath here. Generally, these are all made in the same piece, okay? And these are prefabricated by a fabrication company, steel fabricator, and they're coming out and you're setting them after you do your layout spacing. And they drill and bolt this stuff, and this is very expensive constructions. Built-up column support matches and truss thicknesses. There was a company that specialized in wood laminated glue rigid frames for churches many, many years ago. I don't even know if they're still in business, but they were like a rigid frame, except they were all glue lam, and they look really cool, but they weren't cheap. Let's see, here's another detail. This is reinforced concrete or masonry bearing wall, and the same detail. Now, why this is an open heel, and this is, why this is an open heel and that's a closed heel, I have no idea. This could be a closed heel, all right? All right. The problem with the closed heel plate is that you've got to be really careful with this distance layout, right? At least with an open heel, plate, you've got some wiggle room, right? All right, you got a little wiggle room. Maybe it hangs out 1/4 of an inch, because you're not doing machining. You're not holding it to 1/10 of an inch. 1/10,000th of an inch. I mean, your tolerance in this is not 0, 0, 0, 1 of an inch. Now, in my machining, this is where I live. I live here in the 5th decimal place. If not, you're not a machinist. But construction, you cannot be in this mindset. You'll drive yourself into an insane asylum. There ain't no way on God's green earth you can hold these structures to that kind of tolerance. You'll see in your building codes your tolerances be plus or minus 1/4 of an inch, plus or minus 1/8 of an inch, plus or minus 1/16 of an inch, depends on what it is of the building. Okay, you give me a structural engineer and figure out what that tolerance is. Okay, you got a high-rise steel building going up with all those connections and joints. You know as well as I do, you cannot hold it to a super tight tolerance. There's got to be some room to wiggle through there and construct all that. Put all that together. Now, I'm not saying being sloppy, but again, it's the degree of tolerance. We ain't going to live here in normal construction land. Machining, you better be able to live there. Okay, if I chamber my new 1,000-yard prone competition rifle over into this decimal place, I couldn't hit a barn. It has to be in here for it to be that precise. Okay, you get a job with SpaceX, you better be in here. Okay, anyway, enough of that silliness. Here's the last page. Yahoo! Okay, the last page. Yippee-ki-yay. All right, we're at 1 hour and 42 seconds. All right. What are we at? We're at 1 hour and 1 minute. All right, we'll kill this off pretty quick. Sheathing requirements are similar to those conventional rafter. Why we're repeating this, I have no idea. These details here are important. Y'all can read stuff up here. I don't care. Wood truss rafters. Okay, these are pre-engineered. Okay, fine. All right. This is a pre-engineered roof truss rafters. This is what you buy from a rafter company. A truss company. And these things are designed. They're certified. They're warranted. They have their engineers working on them. Yes, when you get these things stuck up, you're going to have lateral bracing. And don't think your lateral bracing is going to run all the way through in one single piece. You'll start sticking these things. You'll lay out this top plate. You're going to bring a crane in here. You're going to set these. You're going to have a top tie bracing, and then you'll have these lateral bracings, and then you'll start stacking these in and sliding these in and getting them set up. A lot of times you might see temporary bracing on the outside like a purlin, and they might use duplex head nails in it so they can pull them. Everybody knows what a duplex is, right? A duplex nail is like a nail that you use for concrete forming. It's got 2 heads on it. It's got 2 heads. That's a duplex nail. You use this a lot in concrete forming. You want to put a point on that? Yeah, we'll put a point on that. Okay. All right. So this would be, you drive this down to the wood or into the wood. You know, Bubba with a 20-ounce framing hammer is going to drive it deep into the wood. And then when you get ready to pull it, you've got an exposed head to pull it. So if this was a concrete formwork, when the concrete hardened, you could yank that out of there and knock off the concrete forms and be done with it. So sometimes they might use that up here as they're starting. And then when they get enough of these lined up and they're level and they're plumb, then they'll start sliding these lateral bracings in. These will be a permanent addition to your structure. Okay. Wood decking's the same. You can turn this all into a diaphragm. Once you get all this up and get it screwed or nailed in, it's makes for a good deal. Okay. And truss rafters can be supported by anything. All right. Who cares what it is? It could be a concrete wall. It could be a tilt wall. Could be anything. All right. Now, a pitch range is 2 to 12 to an 8 to 12. Okay. And the depth range is a span divided by 10 to a span divided by 20. Get with the truss manufacturer. Say, hey, I got a span of this. We're going to hold this. Look in the catalog. Look what they've certified. Look what they've engineered. And you get with their people. All right. Ceilings can be applied directly to the bottom cords. We've already talked about that before. It can, just like in any kind of support up here for the ceiling. It could be a suspended ceiling. Could be sheetrock nailed up there. All right. But again, however you're going to do this, all this load has to be calculated and determined. If you're going to hang equipment in here, like air conditioning systems, HVAC, plumbing, all that adds to load. Check your code with your engineer. All right. Maximum extension, 2 feet maximum extension of top cord for overhangs. Greater overhangs up to the 1/4 points are possible with the use of wedge blocks or struts. See these wedge blocks or struts on the very end down here? Okay, can give you a little bigger overhang. And again, this is no different than it was a stick frame deal like in a conventional wood framed house. Our light gauge steel. They come down here. Here's our eave detail. Here's our soffit. Here's the vent. Here's your fascia board. Come down here and put your drip ledge, and then right here you're going to have your 1x2 offset for your flashing to keep it away from your fascia board. And this detail right here for down here in Houston is very important because of the water. Okay, overhang eave. This you're just using the overhang of the truss as your eave support. Okay, you don't have to do the lookout gizmos, right? Okay. Here, this is setting back up in here, like in this detail. This detail here, right, is reflected in here. All right. So if you're going to put you're going to close your soffit in, then you're going to have to come in here with a backer, and then you're going to have to put in your lookouts, and cantilever these out, and then put your fascia board on it, and if these don't come bobbed at that angle, which they should, then you got to put your eave plate in, and you may have to come in here with another nailer to support that, depending on how much you got, how much room you got. Again, you got to look at all these details from the fabricator and figure it out. That's what you get paid to do. That's why you're the brainiac architectural designers, right? Okay. All right. So here we go. Think we're done. And so nothing's holding you back but your imagination and your construction budget. All right, that's not too bad.